Chandras Misra from ABES Engineering College, Ghaziabad. In this lecture, I am going to discuss introduction to graph. So, we'll discuss introduction to graph, definition of the graph, graph versus tree, basic terminology, and applications of graph. So, graph in a data structure are used to address real world problems in which it represents the problem area as a network. So we can take any example of graph as like social media networks or telephone networks or any other kind of networks that are represented in the form of a graph. So here we have one example as a social graph. Here we can see uh, their persons and we represented their relations. So nodes are representing the persons and edges are representing the relations between them. So Surabhi and Aditi is here. So Surabhi and Aditi are sister-in-law, and Surabhi listened to rock songs, and Surabhi married to Amit. So this is the relation between Surabhi and Aditi, relation between Surabhi and Amit, and there is some connection between Surabhi and rock because Surabhi listened to rock. So like this, we can represent uh, the real world problem using graph. Here also we can have Manish who works for ABES like this. Okay. So if we talk about definition of the graph, a graph is a non-linear data structure consisting of vertices that is also known as nodes and edges, that is lines representing the connection between nodes. So a graph can be used to define pairwise relation between the objects. So if we write the definition of the graph, we can say graph is an ordered pair. Let's say G is the set of V and E, where V is the set of vertices, or we can say nodes, and E is the set of edges. Okay, so here we have one graph. Here nodes are A, B, C, D. For above graph, vertices are A, comma B, comma C, comma D. A, B, C, D are the vertices. And edges are represented with the pair of vertices like AB is one edge. We can say here one is AC, and then BD is another edge, and CD is another edge. So basically, edges are represented via the pair of vertices. Okay. If we compare a graph with a tree, so there is similarity and difference. So similarity is what both tree and graph are non-linear data structures that contains nodes and edges. In both we have hierarchical data structure. So what is non-linear data structure? Any data structure that form any hierarchy is known as non-linear data structure. And same thing is there in the tree and we have in graph. But what is the main difference between tree and graph? So the tree does not contain any cycle, but the graph may or may not contain cycle. So that was the basic property of the tree. If we have n nodes in a tree, there can be only n minus one edges that is connected. But in graph, it is not necessary. In tree, we always define a root element. This is mandatory to access any tree. But in graph, there is no need to define the root. Okay. So here are some basic terminology used in the graph, like the degree of a vertex. So what is the degree of a vertex? Number of connection the number of connections to the vertex is known as the degree of the vertex. So here we have A, B, C, D, and E as the vertex. So if we try to find out the degree of the vertex, so let's take A. So how many edges are connected to it? There are two edges. So we can create one table like this. Here we have vertex, and here we have degree of these vertices. So let's take example as A. So here it is connected with two. There are two edges connected to A. So the degree of A is 2. If we talk about B, so there are three edges connected to B. So degree of B is 3. If we talk about C, so the degree of C is what? 1, because 1, it is connected with one vertex. If we talk about D, so D is connected with two vertex. Two edges are there from D, so it is having 2 degree, and E is not connected with anyone, so the degree of E is 0. So like this, we can calculate degree of the vertex in a graph. Here we have taken undirected graph. So in the case of directed graph, it will become in degree and out degree. So if we have undirected, if we have directed graph like this, we have so A, B, and this is C. So if we calculate, so we have to calculate in degree and out degree. So out degree of A is 1, but in degree is 0 because no incoming edges at A. So this is 0. Out degree is 1. Out degree is 1 and in degree is 0. So if we talk about B here, 1 in degree and 1 out degree, because one edge is coming and one edge is going outside from the B. So on B, we have out degree as 1 and in degree as 1. In C, we have out degree as 0, but in degree as 1. So like this, we can calculate in degree and out degree of the. This is the basic things that we know before going to perform any operation or study graphs. So here adjacent, if you talk about adjacent vertices, so vertices that are having direct is between them, so that are adjacent vertices. So if you take this example, C is adjacent to B and B is adjacent to C. So if we try to find out adjacent vertex of B, so edges, vertices that are connected, directly connected to B is known as adjacent vertices. Or we can say the vertices that are having direct connections from B are known as adjacent vertices. So clearly we can see here A, D, and C are adjacent vertices. So A, D, and C are adjacent vertex of the adjacent vertex of you can call ADJ adjacent vertex of B. So like this, we can find out adjacent vertices of B. Now, one more important term that is used, path. So path is the way to reach one from one node to another node. So if we take example of two pair of vertices A and E. So what are the ways to reach E? So we can see here, we can go from A to B, then B to C. We can go from B to C, then C to E. So one path is A, B, C, and E. Another path is what? A to D, D to C, and C to E. So it can be A to D, A to D, D to C, and C to E. So there can be many paths between two vertices. So we can calculate these paths. So it is also important terminology in the graph. Now, what are the applications of graph? We can see Google Map is the very good example of graph. So in the Google Map, cities are represented as the nodes, and the path between them are as a we can see as a connection. So like this, we have Ghaziabad, Noida, Ghaziabad, Noida, Delhi, and like Meerut. So we have these cities, and we can have connections or path. Is there any direct path between Ghaziabad and Noida? Yes, we have. Noida, Delhi, yes. Have. We have from Ghaziabad to Meerut. Like this, we can choose. So in the Google Map, there are some algorithm like Dijkstra algorithm is used to find out the shortest path from one city to another city. So that is very good algorithm used there. We'll discuss this algorithm later on in this series. Here, social networks like Facebook, Instagram, LinkedIn are also we can have like the example of the graph. The connection of the between friends can be represented using the graph. In the World Wide Web, links are connected, and these are connected links can be represented with the help of graph. And another important application in the computer science engineering, that is RAG, resource allocation graph in operating system. So we have resources, and what are resources allocated to which process can be represented with the help of operating system, with the help of graph in the operating system. So these are the applications of graph, and we'll discuss the types of graph and their representation there next lecture. Thank you.